My name is Angela Aponte, and this video presentation is for ME 490. My chosen topic of study is 3D printing of a centrifugal ventricular assist device to reduce post-implantation bleeding in end-stage heart failure patients. I swear to abide by the NJIT Honor Code. This is my original work, and all other work shall be cited accordingly. Millions of people around the world suffer from end-stage heart failure. As a mechanical engineer, I have an interest in the biomedical field as well. And if I've learned anything from my undergraduate career as an engineer, it's to face any challenge with a plan of action and fail in order to learn and improve. My project is based in the realm of biomedical engineering, and I had to do months of research just to have a basic understanding of heart devices, blood flow, and heart diseases. Although I may not be fully versed in this field, as a mechanical engineer, I can offer a solution based off of what I know, such as fluid dynamics, solid modeling, stress analysis, and just plain old research. My proposal covers the risk factors of using VADs, as well as supporting arguments as to why a centrifugal pump has a better biochemistry than an axial pump. My report covers some fluid dynamic equations that I'm not going to go into here, but I learned about the mechanics of pulsatile flow and Wormsley number. Ventricular assist devices, or VAD, is a mechanical pump that supports regular heart function and blood flow. The VAD is composed of a pump, a power source, a control unit, and tubes, which carry the blood out of your heart and into your blood vessels. VADs are connected with a cannula to the heart and then to the aorta. VADs can be implanted in patients who are waiting for a heart transplant or as an alternative choice if the patient is not eligible for a heart transplant. There are always risks when using VADs, such as gastrointestinal bleeding, infection, device malfunction, and acquired von Willebrand factor disease, which is a disorder in which platelets are altered and blood clots are common and fatal. This occurs because of the shear stress induced by high speeds of the pump. My prototype will combat these issues in order to hopefully eliminate the risk of acquiring the von Willebrand factor disease. As shown by the infographics, you can see that the centrifugal pumps cause significantly less shear stress than axial pumps. Less shear will cause less damage, and thus this is one of the reasons that it is a more favorable choice. The chart to the right also shows shear stress versus platelet activation. The platelets will eventually cleave and be destroyed when the shear gets too high. Platelets are the ones that help clot. My prototype will be a 3D printed housing of the pump modeled after hardware 2. Same size and dimensions, but less expensive, less heavy, and less hassle. PLA and ABS are favorable materials to print with because they are biocompatible with the human body. PLA is slightly more favorable for its high tensile strength. I chose to make my solid model from PLA, and I did a stress and displacement analysis using SolidWorks. As expected, there was stress and strain on the shaft, but this is still a relatively safe zone. If I had proper equipment, I would love to test this for real. Sadly, I was not able to connect with the hospitals that I reached out to. I could not test my proposal, and that's understandable. People are busy, doctors are busy, and also I need FDA approval, medical board approval, doctors, and a sterile environment. Time and money as well. But if I could, I would model my testing schematic like the study done by Dr. Gilma at the University of Vienna in Austria. Dr. Gilma performed this study in 2016, pretty recently, and concluded that LVADs are indeed causing some anomalies in blood plasma and eventually causing the von Willebrand factor disease in patients. I would model my research just as he did, but by using my prototype against the standard of the hardware 2. To the left of the schematic, you can see his results: normal blood plasma and the LVAD patient's blood plasma. Von Willebrand factor disease has caused many patients to die while waiting for a heart transplant. If I could move forward with this project and get funding and help from doctors, I would in a heartbeat. Forgive the pun. My report contains a comprehensive analysis on blood flow, speed parameters, testing setup, and solid modeling. Thank you so much for watching my video. If you have any questions or concerns, please feel free to email me at aa756@njit.com. Thank you.